Okay, so with some problems, can you hear me? Okay, everything is okay. Okay, so after some technical problems, we can get started. Hi everyone, I'm Piotr. I came across the ocean here to talk about portability, holy grail of portability. So it will be, Mike, can you hear me now? Okay, great. Okay, so let me repeat what I said. I came across the ocean to talk about portability. It will be partially a more philosophic lecture, partially technique. So first, something about me. I work for Solpeo. We develop a game engine fully written in JavaScript, and we are creating it for multi-platform purposes. So basically, I worked there for 5 years, and I have more than 10 years of experience in web development and stuff like this. And what this speech will be about. So first, I want to ask a question: what the portability really is for us, and why we bother. Then I want to go through the process of creating a multi-platform API. I want to discuss different approaches, how to do it. I also want to talk about challenges and limitations. Limitations are well-known things about portability. And at the end, I want to show some demos. Also for the people who ask some questions, we have some giveaways. So quiet. Listen carefully. Okay, so let's get started. What does multi-platform really mean? Well, multi-platform usually means that we create an app, a game, or anything like this for both web and native. By native, we usually mean mobile devices on iOS, on Android. That's what we usually mean by portability. But we wanted to go further with this. We wanted to create something that would make it possible to create games for embedded systems, like, for example, slot machines in casinos, like for these small screens in airplanes that I stared for 20 hours in the plane. And that's what we wanted to achieve. And we wanted to achieve this by one code base. So to make it more simple, we want to create an app with one code written in JavaScript and just to port it simply to any device that we can imagine. And we also want to support all kind of features that every device have. So how it should like? So at the beginning, we should, of course, write the code. Then we should click a magic button. That's how it would look like. Deploy button, and we just run it on a platform. It sounds simple, but how we do that? Well, let's start from the beginning. So from the design perspective, how to design a cross-platform API for such purpose. There are two different approaches, actually. The usual approach is to first design. Before you get to the implementation, you usually design an app, an application, an API, and then you implement it. But there's also a different approach that you first implement, and after you implement, you actually design the API. That's the approach that we took. And it's more like you first implement, then you design, and then you implement, re-implement it again. I'll show how it works later. On an example. We took an example of a simple demo. I'll explain in a minute what's the demo about. But we decided to create a demo in every technique, every technology that we wanted to support. So we have 3 technologies connected to web, so Canvas, DOM, WebGL. And also we have a technology called Qt. I don't know if any one of you heard about Qt. Basically, okay, there's one guy, and okay, more. Qt is a multi-platform technology that makes it possible to create native applications for most of platforms, even embedded systems. And it also has something called Qt Quick, which has a QML language, which is some kind of hybrid of JavaScript. And that made it possible for us to implement our plugin for it to make it easy to create games, create applications for every platform we wanted. So how this demo looked like? Well, it looked something like this. So an epidemic. So we have a bacteria, healthy bacteria that are black. We make an explosion somewhere, which is an epidemic. Then how did this healthy bacteria got infected, and after a few seconds they got ill, and they chase other healthy bacteria to infect them too, and so on and so on. So we created this demo in every technology we wanted to support. And this way, we managed to get all functionalities, all best functionalities from every technology. We only didn't take anything from DOM because it just sucked. But basically, it was as here. So we wrote a simple demo. We picked things that we liked, for example, from Canvas technology or Canvas renderer. We took a simple game loop. Usually, when you create a game, you create something called game loop. In HTML, it's usually a callback for request animation frame. So it was actually great. It was really flexible. So we took this functionality for our API. But we also took something from Qt. Qt has, as I said, QML, which is declarative language. So it makes it easy to create very complicated components in a JSON-like and JavaScript-like language. And after that, we took these things, created some abstract API. It looked quite good. So we started to implement after that. And how that implementation looked like? Well, we had 3 different approaches. First, let's look at the code to implement. It's some kind of abstract code. I want to show it just to make a point what are the techniques of the implementation. Let's say we have an item, some kind of object that has visual representation on the game scene, and it has some 3 methods. These are abstract methods. They would look like differently in Canvas, in DOM, in WebGL, and in Qt. But for now, they are empty. They are ready to implement. So what do we do? Well, there are 3 techniques that I know. First of them is the override technique. We just remove this class and re-implement it again with some, I took as an example a Canvas implementation. So this CTX variable is just a Canvas rendering context. So this technique just replaces the whole class and we re-implement the whole API. This abstract API is just some kind of interface that we want to implement. And well, this technique has some pros and cons. Pros are that it's easy to do that. You just replace it, re-implement it, and it's great. But cons is that in bigger projects, it's really hard to manage. There's lots of code that you actually copy-paste because abstract is not actually empty. In a real API, it has some validation and so on and so on. So actually, when you remove this code, you have to copy-paste it from the abstract. There's also something called monkey patching. It's really nasty, but flexible and just works. Basically, it's some kind of hybrid of override, but you just replace something you want to implement. So, for example, replace the rotate method and re-implement it with a new functionality. And that's it. In smaller projects, it's really great. It works. And it's really easy to do that. But in bigger projects, when you have a lot of code, it's hard to manage. And if you want to also unit test your code and so on, you have a CI, and it's really hard to manage this kind of code. So we choose the third option. Third option is something called abstract implementation. It's a way of implementing with something called abstract implementation. So you have an abstract API. So let's say it's a kind of the box. You connect to it with another box that is called abstract implementation. And this box communicates with both this abstract API and implementation API. And this way, it's really easy to actually manage this kind of code because, for example, you can write the abstract API this way, do some input validation, do some stuff, document it, and you actually really know how it works. And in a slide before, as you can see, this abstract implementation is empty, but it's ready to implement. So this way, we choose this way as this was the best, we think it's the best way to support many devices, because if you want to support new platform, you just write a new implementation, you have a designed API, and you just sit down and do it. There are also some limitations. You all know that portability is a phrase that usually people don't really like. They think that it doesn't exist. It's impossible because there are so many platforms, and it's hard to design one API for all of them. They are so different that it's really hard. So basically, the disadvantage of multi-platform, of portability, is that more platforms you support, less functionality you get. Because you actually get the sum of functionality is a common denominator of all platforms that you want to support. Another thing, as you all know from HTML, there are some differences in APIs. The same API, the same functionality has different API, as sound, as offline storage, etc., etc. So these are the limitations. And talking about native support, there are also some drivers differences on different platforms. If you want to support even embedded systems, it would be really hard to do that. Fortunately for us, Qt resolves this problem for us. We just wrote a plugin written in JavaScript, and Qt community just solves drivers problems or any cross-platform problems for us. That's why we choose this platform. Demos. I wanted to show you some demos. I had it on Linux. Unfortunately, it couldn't connect to the screen. But if someone wants to see a native demo, here, come on after the presentation. I'll show you how it works. I have prepared a demo called Bunnysphere. I'll show you it in a moment, just to have to find it. It's probably here, 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 and here. Or not, yeah, it doesn't work. Okay, so either way, if someone wants to want to see these demos, come on over after the presentation and I'll show it to you. So this is it. This is all from us. If you have any questions, please ask now.